All right. Good evening, guys. Am I audible? Is my voice loud and clear?
Yes.
All right, Amar. Thanks for confirming. Let's get started. Just quickly sharing my screen. All right. Is the screen visible to every one of you? Yes.
Yeah, screen is also visible.
All right. Great, guys. Okay. So yesterday we visited some basics of statistics. We looked at the definition of statistics. We looked at the types of statistics as well, right? So let's just quickly summarize what we did yesterday. Okay. I'll just do a high level summary for those who are attending for the first time. Okay, so this is the day 2 today. Okay, so yesterday we looked at the definition of statistics. Okay, then we looked at two types of statistics. Okay, so one is called as the descriptive statistics, and one is called as the inferential statistics. Okay, as a part of descriptive statistics, we talked about two methods. Yes, numerical methods. So what is descriptive statistics all about? It just describes the data, right? So there are two ways to describe the data. One is through numerical methods and the other is through graphical techniques. Okay. So as a part of numerical methods, again, we have two different ways to summarize or describe the data. One is your measures of central tendency and the other is your measures of variability. So as a part of measures of central tendency, what did we look at yesterday, guys? Do you remember? Anyone? Median. All right. Yes, Sirisha. Mean, median, and mode. All right. As a part of measures of variance, we looked at, or variability, we looked at a range, variance, and then we looked at standard deviation. That's right. All right. So I hope you guys understand what is meant by measures of central tendency, right? So basically, be it average, be it median, be it mode, they represent the values around which the data set is centered around, right? So if I have to go for the measures of central, do you guys remember we discussed yesterday? Now, when should I go for mean and when should I go for median as a measure of central tendency? What is mean? Mean is nothing but an average. Yes, Gangotri. So the presence of outliers determines whether you should go with mean or median. Oh, Sankirtana, my voice is breaking. Is it? How about others? Am I audible? Loud and clear? Sirisha says yes. So Sankirtana. Okay, now okay. All right, Monica. All right, great. Great. Okay, Sandipan, that's fine. So tell me, guys, when will I go for mean as a measure of central tendency and when will I go for median as a measure of central tendency? My data set, I should go with median. That's correct. If there are outliers present, yes, go with median because median is not affected by the presence of outliers, right? And if you don't have outliers, you can go with any mean or median, right? Anything is fine. All right, good. Now we're going to extend a bit, okay, today. So we couldn't cover the graphical techniques yesterday. So we're going to look at few of the graphical techniques today, and that will cover our entire descriptive stats. Okay. All right. So let's jump into graphical techniques or the visualization techniques. All right. So this we did, yes. All the GMAT scores, okay, scored by the students of an MBA class, or you can think of your any final year, any subject, whichever was your main subject, right? Think of the scores being represented by these numbers representing the scores. Okay. Now, if I give you just a list of all these scores, do these scores make any sense to you, or are you able to derive any conclusion or draw some inferences or draw some insights from this data by just looking at it? Can you draw any inferences or insight by just looking at those scores or numbers? Or do you think there is a better way to represent the data so that the people who are looking at the data or the target audience to which you are presenting your data should be able to make some sense out of the data that you're trying to present to them? So if you look at this particular numbers, those are just set of numbers, right? From that, you cannot do anything, right? You need to perform some operations, okay, so that you can in slides to the higher management. The management or the target audience, right? The C-suite people that we talked about yesterday, if you remember, right? The business folks who are going to take some business decisions, right? Based on the data. So they would like to have a clear and concise understanding of what the data is trying to say, right? So for that, it's imperative that we represent the data or show that inferences or insight by the means of some graphs or some visualization techniques. Variable name, Suresh Babu, you can assign a variable name, right? So these are all scores. Okay. It is just the way it has been represented. Okay. For now, I just written them just because there is space on the sheet. Let's assume that way. Okay, Suresh Babu, does that address your concern? Okay, great. So let's move ahead. So what we can plot with the data that I just showed you, probably we can plot something called as a bar chart. Now, what does the bar chart depict or show? What inference can you draw from this bar chart? Paragraph trying to tell some. Okay, 720 is the most, is occurring most time. That is 710, Rohit. Okay, so this is 710. So if I believe this is the one that you're trying to point out. Yes, the bar with the tallest height, right? So this height of the bar represents the frequency. So on the y-axis, basically, we are plotting the frequency. Frequency in the sense, how many times this particular value is occurring in the data set. So as you can see, majority of the students have scored a score of 710 in the exam. Maximum number of persons getting the same. Yes, Gangotri, that's correct. Clear, guys? So a bar chart can help you understand.
So actually, we are missing your voice between. Like for fraction of second, there is no any voice. And again, we are getting your voice like that.
All right. Okay. Is it the case with all of them? Okay. Okay. All right. Maybe there's a network issue. All right. Is it fine now or
Yeah.
should we fix it? Okay. So just put it in chat. Okay. So I'm monitoring the chats. All right. So if you feel that my voice is breaking in between, you're not getting my voice, right? So just ask me to stop in the chat, right? So I'll repeat what. Okay. Okay, let us fix it a bit. Just give me a moment. All right, guys. Am I audible now? Loud and clear?
Yes.
Okay. So seems we have a decent connection, but in between the network seems to be getting jammed. I don't know what, there's huge traffic or because of the rains, it might be an issue. All right, so far it looks good. Okay. So just let me know in the chat. Okay. So Sunil, Sirisha, Rohit, I'm audible now? Okay, cool. All right, so we were talking about the bar chart, okay? So we plot the frequency on the y-axis, okay? And on the x-axis, we plot the actual scores, individual scores, okay? So that is what a bar chart looks like. Okay, so let's move on. Okay, now let us talk about another interesting graphical technique, which is nothing but your box plot, okay? Yes, Rohit, it is right skewed. We'll talk about skewness in a while, okay? So first, let us talk about the box plot. Does anyone know what do we use a box plot? It is also called as a box and whisker plot. If you might have ever seen it in the Excel, Microsoft Excel, and if you go to the recommended charts, you can see something called as a box and whisker plot. Okay. Also, it is called as a box plot. Yes, Rohit. It is used for outliers to check whether the data set that you're working upon. Okay. So basically the feature, the column, or the dimension that you're working with, okay, or the variable that you are trying to analyze, okay, does it contain any outlier? Okay. So let us say if you have a data set like this, okay, and let us say if you have variable 1, variable 2, variable 3, and variable 4, 4 variables. Okay. So to understand if all the 4 variables have some outliers in the values, okay, so for that you have to plot each one box plot for each of the variables. So you have to plot 4 box plots for each of the variables v1, v2, v3, v4, and it will tell you whether there are outliers, okay, in that particular column or that particular variable. Okay, so does the variable contain outliers or not? So how does box plot tell you whether there are outliers? Okay, so if you see this kind of dots, okay, so there's a black dot that you can see over here. This is nothing but your outlier data. Okay, depending upon, so let us take variable 1 over here. Okay, so I just pick this variable 1 over here. Okay, so if I look at the values in variable 1, okay, so let us say I have -11, okay, 1, 2, 3, 4, 5, 6, 7, okay, and so on. Now if you look at these numbers, those are fairly increasing in a consistent manner, but -11 seems to be very far away from the value 1, okay, which seems to be an outlier. So if you have outlier or at the very starting point, okay, so how are these values plotted? These values are plotted from upright. Okay, so this is -11. Then you have your 1, 2, 3, 4, 5, 6, and in that fashion, you can see that the numbers being plotted in that way. Okay, so if I have some values such as 100 as well. Okay, so 100 is an outlier as compared to the other values in the data set. So for 100, there will be one more dot over here, okay, which represents this value 100. Okay, and that will be plotted as an outlier because it is an extreme observation as compared to the other values in that particular column. Okay, so you can have outliers at the bottom of the box plot or at the top of the box plot depending upon the value. Okay, so this dot is representing -11, okay, from this particular column, okay, and 100 is represented over here. Okay, so you can get more than one outliers also if you have more. Okay, if I have 110 as well, so you might have one more dot over here representing. So the number of outliers you have in your column or your variable, okay, those many dots will be plotted in the box plot. Clear, guys? What is an outlier? Yes, Rohit, you correctly identified. -11 is outlier. Yes, similarly 100 and 110 are also outliers over here. Okay, now let us try to understand the structure of the box plot. Okay, what does the box plot show? So if you look over here, okay, so we talked about these dots. Okay, now let us talk about this body of this box plot. So I'll just erase this data a bit over here. Okay, so that we can write something else. Okay, now let us talk about the body of the box plot. Now the body of the box plot, okay, so this one, this is the body of the box plot. Okay, now this particular box, okay, so since this is a box, right, this is called as a box plot. Okay, so the extreme ends of the box are called as, so this is called as your q1. Okay, this middle line of the box is called as q2. Okay, and this third or the top of the box plot is called as q3. This also represents your upper quartile, or also called as a third quartile. The second quartile or q2 also represents the medium, and we already know what is the median, right? It is the middlemost value in your data set, right? So everyone understands that. And in q1 is nothing but the lower quartile. Okay, this represents 25 percentile of your data. Median represents, as it is the middlemost value, right? So 50% of the observations are above it, 50% of the observations are below it, right? So median is representing exactly the 50%, and q3 represents your 75 percentile of the data. Okay, so this is how your data set is divided in the box plot. Now, what are these then? These are called as your whiskers. Okay, so this wick that you see over here, okay, so this is called as your whiskers, and that is the reason the name of this plot is also called as box and whisker. Why? Because this is a box, q1, q2, q3 comprise of this body. Okay, and this is nothing but your whisker. Now we need to understand the length of this whisker so that we can determine this boundary. Why boundary? So in cricket, if the ball is hit beyond the boundary, right, it will be either a 4 or a 6, right? So similarly, if a data point is falling below this lower boundary and above this upper boundary, then we are going to term it as an outlier. Okay. So we need to determine this boundary. Okay. So these are the boundary levels. These are also called as the upper extreme and the lower extreme, or you can just call them as a lower boundary and the upper boundary. Now, in order to determine the values of these boundaries, okay, why do we need to determine the value of these boundaries? Because if we get this boundary or the cutoff value, right, any value which is falling below this and any value which is falling above this upper boundary, we can simply term them as the outliers. So to identify whether a value is outlier or not, we need to set the boundaries. Okay. And how do we set the boundaries, or how we find out what is the boundary? Okay. So for that, we have to find out. So we know the values of Q1, Q2, and Q3. Those are nothing but the 25, 50th, and 75 percentile of the data. Okay. And these values you can definitely figure out from the data set itself. But we do not know how to determine these whiskers. Okay. So in order to determine the length of this whisker, okay, we need to find out something called as the interquartile range, or IQR. IQR is nothing but your Q3 minus Q1 values. Okay. And the length of the whisker is nothing but 1.5 into your interquartile range. Okay. So 1.5 into IQR is what will give you the length of this whisker. Okay. And once you get the length of this whisker, okay, you just need to add this length to Q3 value so that you can get this boundary. Okay. So let us work with an example which will help you understand exactly what I'm talking about. Okay. So these are nothing but the, okay, so this was your vertical box plot. If you just tilt it, okay, if you just tilt it and make it fall like this, it will become a horizontal box plot. Again, the same box plot, you can plot it either horizontally or vertically, doesn't matter. Still, it remains the same. Okay. Only thing is the values will start from over here. So this is your minus 11, 1, 2, 3, and so on. Okay. So here you will have your lower extreme, and this side you will have your upper extreme. Okay. Nothing but the boundary. So this is the boundary. Okay. We need to determine this cutoff or the boundary so that we can say that any value falling below this and any value falling above this is an outlier. Okay. So we have this Q1, we have this Q2 value, and we have this Q3 value. Those are nothing but your actual scores. Okay. So 790 represents your 25 percentile. Okay. Median is represented by 710. Remember the largest or the tallest bar in the bar graph, right? Majority of the students scored this value, right? 710. And then we have this 730, which represents the Q3 value. Now we saw the formula for IQR. Okay. IQR is nothing but, IQR is determined nothing but by Q3 minus Q1. So what is the Q3 value over here? Q3 is 730. Okay. 730 minus Q1 value is 690. So this gives you how much, guys? 40. Okay. So the interquartile range is nothing but 40. Now in order to determine the length of the whisker, remember the length of the whisker is given by 1.5 into IQR. So 1.5 into the IQR value of 40 is nothing but how much? 60, right? So I need to add 60 to this Q3. Q3 is how much? 730. So 730 plus 60 will give me this value, which is nothing but 790. So any student who is scoring more than 790 marks will be determined as an outlier. Okay. And he will be represented by a dot. Okay. Like this. That is nothing but your outliers. Okay. So if any student scores above, or if you have a data point which is above this value, then only it will be represented using dots as an outlier. Similarly, let's find the value for lower extreme. So we know Q1 is nothing but 690. And since we are going in the opposite direction, so 690, okay, we have to subtract 60 from that in order to come towards this side. So this lower extreme will be represented by 630. So any student who is scoring less than 630 will be termed as an outlier and will be represented using the dot over here. Clear, guys, how a box plot is plotted and how we determine whether a particular value is an outlier or not, based on whether it crosses the threshold of upper extreme or lower extreme. If it crosses the threshold of upper extreme or lower extreme on any point, that data point will be termed as an outlier. I hope the example is clear for everyone. We understand how a box plot is plotted. I'm audible, guys, right? Okay, great. All right. So that is how a box plot is plotted. Okay. So let's move on. Let us talk about the frequency distribution plot, which is also called as the histogram. Now, histogram is also called as your frequency distribution plot. Gangotri is the distance of the whisker on either sides always. Okay, so the 1.5 into ICAR is a standard what you can say calculation. Okay, so for that you need to understand what is the normal distribution and stuff like that. And again, it might vary. I'm not saying that is applicable, but in general, that is a value that we take in order to calculate the value of whiskers. Okay, but if you want to read more about how the value is calculated, again, based on the underlying distribution, this can also change. I'm not saying this is going to remain the same, but in general, okay, since majority of the natural, things that you see in this world, right, they all majorly follow normal distribution. Okay, so this formula is coming from there, just to answer your question. All right, coming back to our histogram. Okay, the frequency distribution plot. Okay, so the histogram represents the frequency distribution. That is nothing but how many observations fall within a certain interval. Okay, so for example, talking about the GMAT scores dataset that we were already looking at. Okay, so let us say that we have a range of values from, let us say, 630 to, what was the value that we had? 730. Okay, 730. So students have scored the values between 630 to 730. Now I know this is the range of values the students have scored the marks between. Okay, so what I'm going to do, I'm going to divide this range into equal number of intervals. You can also call them as buckets or intervals. Now, if I select an interval range of 10 in the sense 630 to 640, all the students scoring the marks between 630 to 640 will be thrown in this particular bin. Okay, into this particular bin. All the students scoring the marks between 641 to 650 will be thrown into this bin. Okay, and students scoring between 651 to 660 will be thrown in this particular bin. Okay, which means that we are going to count how many people are scoring that particular marks, okay, into this particular interval or bucket, and we'll keep on just dumping them into this particular bar. Now the height of this bar represents the frequency. How many people have scored these many marks? As you can see, majority of the students have scored marks in this particular interval, that is between 700 to, let us say, 720. Okay, so this is the interval or bucket where the maximum number of students have scored the marks. So the height of the bar represents the frequency, and as you can see, these values are continuous, and that is the reason you can see that the bars are stacked against each other. Whereas if you compare this to a bar graph, you will have distinct bars in a bar graph. So let us revisit that bar graph in a while. So as you can see, one bar represents one single score. Okay, one single score, individual score. It is not representing a range or an interval. Okay, and that is the fundamental difference between a bar plot and a histogram. Clear, guys? What is a histogram? It is nothing but the frequency distribution. Okay, and on this frequency distribution plot that we have plotted over here, right, if you just throw a blanket around it, and the blanket will take the shape of this particular histogram. Okay, if you throw the blanket, it will look something like this. Or you can say that if we join this edges of these bars using a smooth curve, okay, then the plot that you get, this red colored curve, right, this is called as your distribution plot. Okay, how your underlying data has been distributed. Rohit, please repeat difference between bar and histogram. So in histogram, you have continuous range of values, Rohit. Okay. So let us say this is 600 to 610, 600 to 610. Okay. So from 611, immediately this another bar starts between 611 to 620. Okay. So there is no gap in between. Okay. So these are all continuous values showing the range of marks students have scored between 600 to whatever, 750, let us say 780, whatever it is. Okay. So within this range, since you have continuous values, okay, all these bars are stacked with each other. They are close to each other. They are stick to each other. Whereas in a bar graph, one single bar represents one single value in the data set. Here, it does not represent one single value, but it represents a bucket or an interval of 10, which is nothing but 600 to 610. Okay. So this is the bucket size is 10 over here. You can have bucket size of any value. Okay. But it has to stay consistent across. Matlab, here it is 10. Here I want to take from 611 to 630. No, you can't do that. You can't have a bar of value of interval 10, then 20, then 30. No. All the bars need to have an interval, equal interval size. Okay. You can't have varying intervals. You can create a altogether completely different histogram, okay, wherein the bars, the interval size is 20. So all will be 20 in that case. All will be 20 in that case. Okay. So you can have varying bucket sizes, okay, different histograms with different bucket sizes. But within one single histogram, you can't have bars with different bucket sizes. They have to be all of the same bucket size. I hope that is clear, Rohit. All right, great. Are we following, guys, so far? Do we understand what is a histogram or what is the frequency distribution plot? Okay, great. So coming to skewness and kurtosis, okay. So if I draw a distribution plot like this, let us say, now we just now understood what is a distribution plot, right? So let us say if I have a distribution plot like this. Okay. Let us say that I cut this distribution plot exactly at the middle. Okay. I take a scissor. I cut this distribution plot into two halves, two equal halves. Okay. And if I get exact 50% of the data points on one side and exactly 50% of data on the other side, right? So we say that the point at which we cut, right, this histogram at the middle, right, we have got exactly two equal halves. Okay. So we say that we cut the histogram or we cut the distribution plot and we got symmetrical equal halves, right? So in this case, this distribution is said to be symmetrical. There is symmetry in the distribution. Okay. But if I would have cut a different histogram like this, let us say if I would have or had a plot like this. Okay. So this is the distribution of the plot. And if I cut this at the middle, okay. So let us say if I cut this over here using this scissor. Now tell me, am I getting equal halves over here? Is this equal, guys? Are these two equal halves? No, right? Maybe this is 40% of the data. Maybe this is representing 60% of the data, right? So when we cut the histogram into two equal halves and it does not give us the identical shapes of each other, right? So basically we say that there is a certain asymmetry in the distribution. Okay. There is certain asymmetry in the distribution and we want to understand, okay, what is the asymmetry? If you want to quantify that asymmetry, how much asymmetrical is the distribution, right? So that is given by your skewness. That measure is given by the skewness. So skewness is a measure of how much asymmetrical is your distribution. Okay. And there are two types of skewness. Okay. So let us talk about those. So when the tail is formed like this, okay, we said that this is positive skewness or this is, so when the tail, okay. So how do we understand whether it is positive skewness or negative skewness? Remember on the scale, okay. So you have your x-axis, right, like this. Coordinate system. Remember the coordinate system, okay. So here, this is, you have positive X values, and on this side, you have negative X values, right? So when the tail is towards the positive axis, we are going to say that this is a positively skewed distribution. And when the tail is towards the negative x-axis, okay, on this side, so the tail is forming at this side, right, towards the negative x-axis. So we are going to say that this is negatively skewed distribution. Now, if you want to quantify how much negatively skewed distribution it is, okay, so you can arrive at this value, okay, by using this formula. Again, you don't have to remember this, how this was derived, how do I put the values in it, right? Today we have Python libraries which will give you calculate this value for it, and they will give you. But tomorrow, if you calculate the skewness of any distribution, and if it results into a positive or a negative value, you should be able to visualize, okay, which side the tail of the distribution lies. Okay, clear, guys? With me so far? Are we able to understand? Are we able to comprehend what we are learning so far? Okay, great. All right, let's move on to the next term, that is kurtosis. Okay. Now, kurtosis is nothing but the measure of peakness and flatness. Now, what do you mean by measure of peakness and flatness? Let us say if I have a distribution like this, if the distribution plot looks like this. Now, tell me, guys, do we have the top of the distribution? Is it a flat territory or is it like a peaked one? It is flat, right? So the measure of peakness, now here we don't have peakness, but rather we have flatness, right? So this is called as negative kurtosis. We say that this particular distribution has negative kurtosis when there is flatness. Okay, again, under the distribution, as we said, right, there is histogram. Again, these are stacked bars, okay, not individual bars, but these are stacked bars. Remember, we throw a blanket, okay, or we join this edges of the histogram, that is when we get this smooth curve, right? Now, if we have a histogram like this, wherein there is a peak, okay, again, why there is peak? Because there are certain bars which are representing that particular value. Okay, so when you have a very peak, now this is not a flat region, this is a peak region, right? So when you have peakness in a distribution, right, then you are said to have positive kurtosis. Okay, clear? What is positive kurtosis and negative kurtosis? Depending upon the shape of your distribution, you can determine whether you have a positive kurtosis or a negative kurtosis. If you have a flat distribution like this, if the top of the distribution is flat like this, okay, you can say it is negative kurtosis. And when you have a peak getting formed, okay, then you can say like a mountain-like structure, okay, when you have a peak, then you can say you have a positive kurtosis. I hope that is clear, guys. Okay. It doesn't matter, Omkar. We are not measuring the skewness. We are just measuring the peakness of the distribution. Okay. All right. Now let us try to understand the next plot, which is very important plot, okay, called as the scatter plot. Now, when I am interested to find out if there is certain relationship between the variables in my data set, okay, so let us say v1, v2, v3, and so on. Okay, if I want to understand if there is certain relationship between the values of these two columns in my data set, okay, if I want to understand if the values that are there in these two columns are they related to each other or not, okay, if I want to find the relationship between two variables, I'm going to find out that using a scatter plot. Okay, let us say this is the temperature in degree Celsius. Okay, this is variable 1. Okay, the other variable that we have collected is our ice cream sales. Okay, so these are the values for temperatures. These are the values, corresponding values of the ice cream sales. Okay, Now, as we know that when there is summer season, right, definitely the ice cream sales will be higher. Okay. So if you look at the relationship between these two variables, temperature and the sales of ice cream. Okay. As the temperature keeps on increasing, right, what is happening to the sales, guys? Are they increasing or are they decreasing? Are they increasing or are they decreasing? Increasing, right? Obviously. So as the temperature keeps on increasing, more and more ice creams will getting the sales will be happening, okay, for the ice creams. Okay, and that is how you can say that there is a certain positive relationship. Okay, there is certain positive relationship, okay, or positive correlation. The term, statistical term that is used is correlation. We say that the variables temperature and sales are positively correlated to each other. Okay, now we are saying that they are positively correlated. Okay, so the relation, there is certain relationship between sales and temperature. But if I ask you, can you quantify how strongly or weakly or moderately are those two variables associated? Can you quantify the relationship between them? How, Gangotri? How can you quantify? No, when I say quantify, I want you to give some number. Whether there is strong relationship between temperature and sales, whether there is weak relationship between sales and temperature. What do you think? We know that they are correlated to each other. So as the value of one variable increases, similarly, the value of other variable also increases. Okay. So when both the variables travel together in the same direction, in the sense, as V1 increases, V2 also increases. Or as the temperature decreases, the sales of ice cream also decreases, right? So either they move towards the negative side, basically both decrease together or both increase together in the same direction, right? Then we say that those two variables are positively correlated. There is positive correlation between those two variables. Are we clear up till here? I will tell you how to quantify the relationship. But so far, when will we say that there is positive correlation between two variables? Yes, Omkar, you can say they are directly proportional as well. Yes. Yes. Definitely, Akash. That is also the right thing to say. Okay, they're directly proportional. All right, now let us move on to something called as negative correlation. Okay, so let us try to understand what is negative correlation. Now let us say that I have collected the data, okay, for people who are smoking cigarettes. Okay, so let us say people who have never smoked cigarettes, so 0 years, people who have been smoking cigarettes for 5 years, 10 years, 15 years, and 20 years. Okay, so this is the number of years a person has been smoking the cigarette. Not a person, these are different persons. Okay, so this is, let us say this is person 1, person 2, person 3, person 4, person 5. So we have collected data from 5 people. Now this lung capacity is nothing but how healthy their lung is. Okay, so larger value states that the lung is in good condition. Smaller value indicates that the lungs are not in a good condition. Okay, now we have in our statistical language, let us say that we have this as variable 1, this is variable 2. Okay, so for us these are two variables. We are interested to find out how these two variables are related to each other. Is there certain relationship between these two variables? Yes or no? And for that, we know that we can plot a scatter plot to determine what is the relationship between these two variables. Okay, so what we have done, we have plotted these two variables. We have just named them as X and Y. Okay, so X represent the number of years you have been smoking. Okay, years of smoking. Okay, and Y is nothing but your lung capacity. Okay, lung capacity. Now tell me, what kind of a relationship do you see over here? So as the number of years you are smoking, as one variable is increasing, okay, what is happening to the other variable, guys? Is it also increasing or is it decreasing? Decreasing. So as the number of years you keep on smoking increases, your lung capacity diminishes or it starts to decrease. Okay, so as one variable increases, the other decreases, and vice versa. Okay, and vice versa as well. So basically we say that there is a negative correlation. We say that there is negative correlation between these two variables which is years of smoking and lung capacity. Clear, guys? When change in one variable, okay, so basically when one variable increases and the other decreases and vice versa, okay, then we say that there is a negative correlation or negative relationship between those two variables. So far, are we clear? Both positive relation and positive correlation and negative correlation. Is it clear, everyone? This is very basic, guys, and based on this, our machine learning models are going to work. Okay, so you need to understand how to figure out the relationship between two variables. All right, I hope we are clear until here. All good? Shall we move ahead? Okay. So we said that there is a certain relationship, okay, but can we quantify it in numbers? Okay, can we quantify it in numbers? In the sense, can we quantify how strongly they are related to each other? Yes, we can quantify them using something called as correlation coefficient. Something called as correlation coefficient. Okay, now what is this correlation coefficient? This is denoted by a small r. Okay, now this r takes values between, okay, -1 to +1. -1 to +1. -1 indicating strong negative correlation and +1 indicating strong positive correlation. Okay, -1 indicates strong negative correlation and +1 indicates a strong positive, sorry, +1 indicates strong positive correlation. Okay, so this correlation coefficient r is used to quantify how strongly two variables are correlated. Okay, so Kushi, that is not ascending and descending. Okay, ascending and descending is a trend. Okay, but that denotes whether when you change one variable. Okay, so basically when you increase one variable, okay, what happens to the other variable? If the other variable also increases, okay, and both travel in the same direction. If it decreases, v1 decreases and v2 also decreases. Okay, so they are they're moving together in the same direction. Then we say that they are positively correlated. But when change in one variable, okay, when one increases, then the other decreases and vice versa, then we say that they are negatively correlated. Okay, and the arrow is nothing but the data points. When we plot it on the scatter plot, right, they will tell you whether they are moving together in the same direction or moving together in opposite direction. Okay, so that direction basically tells you whether they are positively correlated or negatively correlated. Is that clear, Kushi? All right. So we were talking about quantifying the relationship between two variables using a correlation coefficient r. It is also called as a Pearson's correlation coefficient. Okay, let us talk about Pearson's correlation coefficient. Okay, so as I said, r can take the value between, okay, r can take the value between -1 to +1. Okay, -1 indicates high correlation on the negative side, +1 indicates high correlation, strong correlation on the positive side. Okay, and when r is equal to 0, we say that there is low correlation or almost there is no correlation. Okay, okay, the formula to calculate r, okay, again we don't have to learn or by heart this formula of how this r is calculated. Okay, it involves basically the calculation using mean. Okay, so x is nothing but the one variable v1, okay, and y is nothing but your variable v2. X bar and y bar are nothing but their respective means. Okay, and we perform this calculation with those values to arrive at the correlation coefficient value of r. All right, okay, again we have Python libraries to calculate this, so you need not do this manually. Okay, so as we said, we talked about what r lies between -1 to +1. Okay, so a value between 0.1 to 0.3 of r, be on either side, positive or negative side, indicates it's a weak correlation. And then the value lies between 0.4 to 0.7 on either sides, be it positive or negative, it indicates moderate correlation. And a value between 0.8 to 1.0 indicates a very strong correlation. Again, it can be -0.8 or +0.8, depending upon whether it's a negative correlation or a positive correlation. Okay, so clear, guys, how we can quantify the relationship between two variables? I hope that is clear. All right, Sirisha. Okay, so this is the graph to depict your perfect positive. So this is perfect positive correlation, guys. And this is a perfect negative correlation. So when you join the dots with a line, it might almost look like a linear relationship between the two variables. Okay, so this is a bit moderate correlation, as we said, right? So between 0.8 to 1.0 is strong correlation like this, and this is 0.70. So this is 0.70 on the positive. So you can see that this is a positive correlation. Okay, and this is a negative correlation. Okay, that is the reason you can see minus 0.70. And when we have a graph like this, okay, we'll say that there is no correlation when R takes the value of 0. All right. So this is again to show a similar other values of R, correlation coefficient R, and how the respective graphs may look like. So you can just imagine these as graphs, okay, like this. So this is no correlation. Okay. So this is when there is linear relationship between the two variables, okay, but your variables might also be in a non-linear relationship. Okay, so these are all non-linear relationships. So for non-linear relationships, you cannot measure the or you cannot quantify the relationship between your two variables v1 and v2 using Pearson's correlation coefficient. For that, we have to use a different measure. Okay, so there are different methods to quantify the relationship between two non-linearly associated variables. The correlation coefficient R that we talked about just now is basically for linearly associated variables. For non-linearly associated variables like this, we have to use different measures. Okay, so that is out of the scope of this particular discussion. But yes, you can definitely find out what other methods exist to quantify the relationship between non-linearly associated variables as well. All right, guys. We talked about this lung capacity, right? So we can work with the X bar and Y bar, okay? Plug in the values into the particular formula that we looked at for correlation coefficient, and we can quantify it as 0.96. So on the negative side, so that is why we have a negative value. You can see that lung capacity and your number of years smoking, right? So this is a negative correlation. So that is nothing but the same. Okay, guys, that was something which we should have covered yesterday itself. Okay, so that concludes our day 1. So I'm going to jump off to day 2 slide now. Okay, any questions before we jump into our next part? Oh, Kushi, I think I explained, right? What are the bottom graphs? So those were the non-linear relationship between the two variables, X and Y. So when you have non-linear relationships that exist between two variables, you cannot use Pearson's correlation coefficient, but there are other methods to determine or quantify the relationship between those non-linearly associated variables. Oh, don't worry about those. Those are nothing, just fancy names. All right, Kushi. Okay, Rohit, any sort of we should discover. Sorry, I didn't get your question, Rohit. Probably can rephrase what you're trying to say. Okay, so in the meantime, I'll just go full screen. So we already had an introduction about me. Okay, so today we are going to look at unsupervised and supervised machine learning techniques. Okay, anything other than, oh Rohit, there is a lot of things that you should know, or you can discover, or you can learn about, right? There are a lot of things, but you should take baby steps. Does baby, on the day when it is born, does it start running? No, right? You should learn one single अक्षय रजाई सर थोड़ा हिंदी में बताओ. Okay, Akshay, I'm not sure what kind of audience we have, whether people understand Hindi. I know it's our national language, but some people prefer English over other language, and that's the reason I stick to English. But nevertheless, if majority of them understand Hindi, I might have a mix of both. Not an issue. Anything other than this? So Rohit, there are a lot of things. बहुत कुछ है सीखने के लिए. Okay, but baby when it is born, right? वो जैसे ही जन्म लेता है भागने नहीं लगता, right? it takes one step at a time, right? So you should learn one step at a time, slowly learn one single concept every day, okay? And try to inculcate or try to comprehend, okay? Try to find its applications, implications, how to do that, how it is derived, okay? So one step at a time, one baby step at a time, I would say, right? And then you will be able to start running in couple of days, okay? Similarly, if you want to learn some new language, right? Agar aapko nayi bhasha seekhni hai, what do? First you learn A, B, C, D, then you form words, then you form the sentences, then you form the paragraph, right? So you go step by step, okay? So keep learning one concept at a time, and over a period of time, you should be able to grasp or have a good hold over the remaining concepts. Ayush. Yes, I can speak multiple languages. All right, guys, let's come back to our topic. Sakshi, I would have loved to take a break, but then we covered something which we should have covered yesterday only. Okay. So we are already lagging a bit. If you guys want, we can take a break, but since this is being streamed live and it is getting recorded, you can always take a break and revisit the recording when you want to. So what do you guys prefer? Should we continue? Or do you guys need a break? Okay, continue. So majority of them are saying continue. So let's continue, guys. Okay, so we are going to talk about supervised and unsupervised machine learning techniques. So for that, first we need to understand, okay, what is supervised, what is the difference between supervised and unsupervised? Okay, so let us say whenever you go to a bank to apply for a loan, right? So what are the information they ask you guys? Do you remember? Have you ever seen someone applying for a loan? Do they ask for some information from you? What kind of information they'll ask from you? Probably they'll collect your name, okay? So from person 1, person 2, person 3, and so on, 100% apply for a loan, okay? So they'll ask your name, the city where you live in, right? Your salary, okay? Or are you a business person or a salaried person, for example? What is your CIBIL score, and so on, right? Yeah, a lot of papers, right? Sirisha, personal details, your financial details, right? They will want to ask everything about you, right? So basically, whenever they want to arrive at a business decision of whether I should give the loan, yes or no. Okay, if I want to arrive at a conclusion whether I should give loan to a particular person, yes or no, it depends upon a number of factors such as the name, city, salary, civil, a lot of such factors, right? There are multiple factors involved. There are a lot of factors. You can also call them as input factors or input variables. Okay, factors, variables. Okay, so there are a lot of values or factors or criteria or variables involved based on which, okay, so let us say we have a person called as XYZ, city, let us say Pune, salary, let us say 40K per month, CIBIL score, let us say 730, right? So all things look good. Yes, pass him a loan. So based on these details, business is taking a decision whether we should give loan to that person, yes or no, right? So these variables, okay, these kind of variables, when you have in your data set, right? These special variables are called as target variables. You can call this as a target variable or your variable of interest. Okay, variable of interest. Okay, or you can also call it as an output variable or outcome variable. Why we are saying outcome? Why? Because what is the use of collecting all these input variables? The reason to collect all these input variables was to determine whether I should pass the loan to that person, yes or no, right? So I'm deriving some outcome based on this input, right? So these input variables are called as your X variables, okay, X variables, and the target variable, variable of interest, or the output variable is also called as your Y variable, okay, or also called as your target variable, okay. So when your data set contains, okay, when your data set contains both X, okay, input variables as well as the output variable, your target variable, okay, and you are interested in predicting your target variable or the Y variable, okay. whether a person will get the loan or not, and so on, right? So when you are interested in predicting based on certain input parameters, if you want to predict whether I should pass the loan to this particular person or not, right? If I want to predict that value, right, I need to build a machine learning algorithm. I need to build a model, okay, based on this data, which will predict whether a certain person, given the input values, should be given the loan or not. Okay. So when your data set contains both x and y variables, okay, contains both x and y variables, then that data set is used for supervised machine learning. Okay. So whenever basically your data set contains the target variable y, okay, there is supervision on the y variable. Okay, there is supervision on the y variable, and that is the reason we call it as supervised machine learning. And when your data set does not contain y variable but only input, okay, so when your data set contains only all the x variables, you don't have a variable of interest or a target variable, okay, in that case, whatever techniques you apply, okay, to generate insights or draw certain inferences, right, on this particular data set, those all techniques are called as your unsupervised machine learning techniques, where you don't have your y variable. You don't have a y variable, okay? So no y variable. Let us say no y variable. Is that clear, guys? Do we understand the difference between supervised and unsupervised machine learning techniques? Simple enough, very much clear. If your data set contains your target variable, you need to apply your supervised machine learning techniques, okay, so that you can predict the y variable. And when your data set does not contain any y variable, okay, no target variable, only you have all the input variables, okay, then you can apply unsupervised machine learning techniques. And today we are going to start with one such unsupervised machine learning algorithm or unsupervised machine learning techniques that we're going to discuss today, okay. So let us start with that. So we're going to discuss about clustering techniques first, okay, and then we'll look at the other ones, okay. So we'll understand what is clustering, okay. Yes, Gangotri, that is what we are going to discuss now. What is the use of unsupervised machine learning, okay, in what scenarios to use, what is the use of it, we're going to look at it now, okay. So we're going to basically look at what is clustering, okay, what is hierarchical clustering, what is k-means clustering, basically why clustering, okay. We're going to talk about that. Okay, so before that, let me show you a picture. Now, is this picture familiar to you guys? We'll discuss about it, Gangotri, don't worry. Okay, is this picture familiar to you guys? Roshan Chaudhary, please type in your response in the chat. Due to the number of participants, the unmute button has been restricted, okay. Mumbai Chet Dabbewale, yes. Onkar, Rohit, Dabbawalas, yes. Providing lunch boxes to office, yes, exactly correct. Now, can anyone tell me what happens? I mean, what is the process? Everyone knows, right? They were awarded with a 6 Sigma operating efficiency, right? Even Prince Charles visited them to understand how they operate, right? So they operate at the highest level of efficiency. Do you know how these guys operate? What do they do after collecting the dabbas from the respective homes? Acha. But yes, we can take that as an example to learn, right, Rohit? Okay, Kushi is saying distribution, all right. But what do they do? Do they send one person to every home? Then they might have to hire so many people, right? Then is that an efficient way of delivering boxes? Collect boxes from home and send to the respective ones. That's correct, Gangotri. Kushi is saying area-wise, okay. Okay, now let us say these are the 4 people who went to respective areas and collected all the dabbas. What do they do next? What do you think they might be doing next? What do they do with all these dabbas? Shirisa is saying eat. Okay, then that defeats the purpose, right? They're providing a service. Okay. Sort accordingly. Yes, Rohit, correct. But sort on the basis of what? How will they sort the dabbas? Do you see there is something written on the top of the dabbas? Yes, divide the dabbas with respect to the area of delivery. Sort them according to the delivery address. Exactly. That's right, guys. Right? So we sort them based on some similarity factor, which is the destination area, right? Where it needs to be delivered, whether it needs to be delivered to Dadar, whether it needs to be delivered to Mahim, okay, or your Victoria terminus, right? Or CST, whatever it is called as, right, these days. So basically, based on the destination address, we collect the dabbas in a certain what you can say, a different crates. You can see these crates, right? So these are the crates over here, as you can see, right? So these dabbas are destined to go at one single. Let us say these are going to the other, right? These dabbas, as you can see over here, might be going to, let us say, VT, okay, and so on. So this might be going to somewhere else, some other destination. So what are we doing here, guys? What is this process called as at a high level? This is nothing but clustering. Yes, exactly, Omkar. Bang on. So this is the process of clustering, guys. Grouping the dabbas based on certain similarity basis. Okay. And the similarity basis, or the sorting is done on the basis of the destination where they need to be delivered, right? So this is how we are sorting all the dabbas, okay, and creating different clusters, okay, and then sending these crates into those respective locals from where the other person at that particular location receives it, and then he delivers the dabbas to their respective offices, right? So this is how the entire Mumbai Dabbawalas used to operate, okay, and that is why we have taken this example to understand the clustering as well. Okay. All right. Let's move on. Now that you guys have understood. So what is clustering? So clustering or segmenting the data, okay, is an exploratory method. Remember, this is an exploratory method, guys. We are trying to explore the data to see if there are certain hidden patterns. We can group the data points based on certain criteria, okay, and basically what is the goal of clustering is to identify homogeneous groups, okay, of records, or basically group together similar records and create different groups for dissimilar records, okay. So similar records should belong to the same cluster, dissimilar records should belong to different clusters. So that is the entire goal of clustering, even though we don't have a target variable. Now do you understand, Gangotri, what is the use of clustering? So even though we don't have a target variable or y variable, we are trying to explore, okay, this is an exploratory method. We're trying to see, okay, what best use we can make with the available data, right? Okay, so Sankirtana is asking where the clustering is used for. Okay, Sankirtana, okay, to give you an example, have you guys heard about credit cards? I know majority of you guys are students, so maybe you're not having, you don't own a credit card, but maybe your, your people in your home, your father, your probably your mother, your relatives, you might have seen the credit cards, right? So does the bank issue same credit card to all the customers, or do we have different types of credit cards? Different types, Sankirtana, right? We have different types of credit cards. Now, why do we have these different types of credit cards? End of the day, you're borrowing money to purchase something, right? You are buying something on credit. So end of the billing cycle, you pay the money back, right? Then what is the purpose of having different types of credit cards? Any thoughts around that? Omkar is saying depending on usage. Okay. What kind of a usage, Omkar? Okay, petrol. If you're using more for petrol, you have petrol cards, right? If you use it for more for shopping, you have shopping cards, right? If you go for grocery, you have grocery cards. There are cashback cards, right? Where you get cashback on offers on all the different purchases that you make, right? So all that stuff. Again, there might be a basis, right? There might be certain criteria, right? Based on which they might be issuing the credit cards to you. Yes, customers repayment capability, Maithili. Yes, you're right. So basically, depending upon what is the repayment capacity, that is one thing actually for sure for issuing a credit card. But we are talking about the types, right? We are segmenting the customers. We are dividing. So let us say if I'm a bank, right? XYZ bank. Let us say I own a bank, XYZ bank. Okay. XYZ bank. I have, let us say, 1 lakh customers. Am I going to go and just give the similar credit card to all the bank customers? No. I'm going to do some analysis of the customers, okay, the bank customers. I'm going to divide them into different income range groups. So let us say I can divide them between 0 to 40K. Okay, then I am going to divide them from 41K to, let us say, 80K. Okay, then people greater than 80K salary. Okay, so I can create these 3 different groups or 3 different clusters, and I can say, okay, issue them basic credit card for these people, issue some what do you call this nowadays, titanium credit card, then you have this platinum credit card. Have you heard about these different types of credit cards, right? Yes, yes guys. So I can cluster, I can create clusters of my customer data based on certain criteria, some similarity criteria, right? Whether they are belonging to this income group, yes or no, whether they are male. I can, create different, for different age groups. For teenagers, maybe a different credit card, maybe for females, or, a different credit card, and so on. I mean, there are different criteria based on which I can, divide. But do we understand the example? Someone asked for an example, right? Where is this used? Now, do we understand this, where I can make use of this clustering techniques? All right, good going. Let us jump into the actual technique now to see how it works. Okay. So why clustering, creating similar things together. We can discover or understand the structure in the data. We can summarize data points by their cluster center. Okay. What kind of business questions can we answer by doing clustering? What kind of customers are there in my market, right? If I own a bank, what kind of customers I have, right? Whether I have majority of the customers falling into the premium category, or salaried people, or people who are basically government workers, and so on, right? So I can cluster or create different groups of customers based on the type of customers I have in my bank, right? So that is one example that we talked about. What kind of people are there on the social network? What kind of emails hit your inbox, right? Spam, ham, and so on. Then what type of genes the human genome has. So nowadays, the application of these techniques is not bound to any particular sector, banking or manufacturing, and so on. So data science can be applied across different verticals. Okay, and bioinformatics is also one of those. All right. So the first technique that we're going to look at is called as hierarchical clustering or agglomerative clustering, as the name suggests. So as we can think of certain hierarchies that exist in different organizations, right? So what is the usual typical organization in any company, guys? We have the CEO sitting at the top, right? Then we have all the department heads under him, right? So let us say if he has 3 departments. So let's say department 1 head, department 2 head, department 3 head, right? And then all the teams below him, right? So is this kind of an hierarchy, guys? Have you seen this kind of hierarchies? Yes or no? We understand this, right? Simple to understand? Yes, top to down approach. That's right. So this is the basis of how hierarchical clustering. See, let us say this is your finance department. Okay. Just to give you, okay. So let us say this is your finance department. This is your HR department. Okay. This is your operations department. Okay. So all people belonging or working under the operations team will fall under this particular group. All people working in the HR team will fall under this group. All people working in the finance will. So these working people or employees have something in common. Is nothing but the department for which they work for, right? So similarly, we are going to take different data points and try to create different clusters or groups based on certain hierarchy. Okay. And what is this measure, or how do we create this hierarchy, right? That is what we are going to look at in the next few slides now. So let us get on to it. Okay. So this is just to give you a understanding of how a hierarchical clustering looks like. Okay. So this is what we try to do at the end of the day. So this is these 2 data points, M is somewhat similar to W. So if you invert the M, it will become like W. So it is somewhat similar to the structure of W, and that is why we have grouped them together into one single cluster. N and U, okay, so if I write N, okay, sometimes if I just overlap these things, this becomes U as well. So that is the reason I have clubbed this. So this is just an example of example is just show you how, based on certain similarity criteria, we can club the letters. Okay, so this is just an example. Similarly thing we can do with numbers as well. Okay, so if I write 4 like this, okay, if I write 4 like this, sometimes we write 4 like this as well, right? Okay, but if I write the 4 like this, it's somewhat similar to 9 as well. Okay, so I can club these two together. So you can see that I can club 1 and 7 because they look somewhat similar. I can club 3 and 8 because they look somewhat similar, 4 and 9, and so on. Okay, so but at the end of the day, I will create a hierarchy of all of these so that it becomes a top-down structure. Okay, okay, now how do we merge any two data points based on, how do we cluster two data points based on certain similarity criteria? That similarity criteria is defined by something called as the distance between them. Okay, and this distance is not a normal distance, but it is a special kind of a distance which is called as your Euclidean distance. Okay, we're going to talk about what is the Euclidean distance. Okay, so on the basis of Euclidean distance, we are going to determine whether two data points. So let us say I'm going to find out the distance from A to B, from A to C, from A to D. Okay, and I'm going to find out the distance from A to E, and I'm going to find the distance from A to F. And based on the distance, okay, I'm going to find out which element is closer to A. I can see that, okay, none of these are closer to A, all are very far from them. And then I'll find out the distance between B to C, B to D, B to E, and B to F. And I figure out that B and C are very close to each other in terms of distances. So I'm going to create a cluster of both of these called as B and C. So I'm going to merge these two data points into one single cluster. So when I merge two data points, okay, so distance between two data points, okay, I can find out using Euclidean distance. Okay, but when I create a group of data points together, okay, that forms something called as a cluster. Okay, and to find out the distance between two clusters, cluster 1 and cluster 2, okay, so if I want to find the distance between two data points, data point 1 and data point 2, I can find out using the Euclidean distance method. We'll see what is the Euclidean distance. Okay, but if I want to find out the distance between two clusters, you cannot use this same Euclidean distance technique. There are some other techniques to find out this. Okay, and we're going to talk about how this is done, okay, in the subsequent slides. But so far, do we understand how are we grouping these data points? We are going to find out the distance between B and C. We are going to say if they are very close to each other, form a cluster. D and I are very close to each other, form a cluster. Then find the distance from A to cluster BC, from A to DE cluster, and then from A to F, and figure out, okay, which ones are very close to each other. We find that distance between F and D cluster is very close, and then we club them together into one single cluster, which is a DE and F. Then we find out the distance between A to BC, A to DF. Okay, and we find out that BC and DF are very close to each other, and then we merge them together. And at finally, A is not close to anyone, but then at the end of the day, we merge them. Now, this is an inverted form of the hierarchical thing that we saw just now in the previous slides. Okay, but any which way, it is inverted or in a top-down, right? At the end of the day, this is a hierarchical clustering that we are talking about, and it requires the definition of distance, which is your Euclidean distance. Now let us try to understand what is this Euclidean distance all about. So Euclidean distance, okay, let us take very simple example. Let us take very simple example. I'm sure you guys are aware of the coordinate system. So I'm going to take a very simple example. This is your x-axis. This is your y-axis. Okay, so this is 0. Now you can plot one variable over here, one variable over here. Okay, so this is how your scatter plot was there, right? And we plotted the scatter plot. Now the same concept of this coordinate system we are going to use for Euclidean distance. Let us say I have a data point A. Okay, and let us say I have another data point which is B. Now if you talk about the values of A, okay, the coordinates of A, this will have certain x1 and this will have certain y1 value, and this B point will also have certain x2 and certain y2 values, right? Since they're plotted on a coordinate system, they'll have certain values, right? Now, if I want to find out the distance, between these two data points A and B, if I want to find the distance between these two data points A and B using Euclidean distance, how do you find out? So the distance between A comma B is given as, okay, square root of, okay, we are going to take the difference between X coordinates and the difference between Y coordinates. Okay, so this will become y2 minus y1 whole square plus x2 minus x1 whole square. So this is how we are going to find out the distance between A and B using the Euclidean distance method. Is this clear to everyone? How do we use Euclidean distance? Using Euclidean distance, how to find distance between two data points? Is it clear? Very much clear, everyone? Because if you are able to understand this for a simple two data points A and B, I'm going to show you when we extend this to the three-dimensional data. So this is two dimension currently. So we have X and Y. So if we introduce a third dimension, which is a Z dimension, let us say if I introduce a Z dimension over here. Okay. So these data points will have X1, Y1 and certain Z1. And it will also have X2, Y2 and certain Z2 also values, right? Because you have a third coordinate. Then these data points will be in space. So the same thing over here. This is data point, this is another data point. So these data points will have certain X1, Y1 and Z1 values, right? So similar to this. So I showed you the two axes because we can easy to understand on a X and Y coordinate system. Okay. If you introduce another third axis, which is Z, okay, it will have another coordinate as well, Z1 and Z2. In that case, we just need to add over here plus Z2 minus Z1 whole square, and that's it. So again, if there are more dimensions, so this is three-dimensional. Now human eyes can visualize only up to 3 dimensions, okay? Because the world that we live in is a three-dimensional world, okay? So if you want to have visualize the fourth dimension, fifth dimension, that is practically not possible, okay? But in real life, we might have more than 3 dimensions. Now, what are these dimensions that we are talking about, right? So these X, Y are nothing but your variables in your data set. These are nothing but the variables in a data set. And if I have to find out the distance between person 1, okay, certain values, and person 2, certain values. If I want to find out the similarity or, basically the distance between these two persons, P1 and P2, okay, I'm going to take these values, okay, in this fashion and find out the distance between these two people, A and B. So let us name them A and B. Okay. If I want to find the distance between A and B, so this is how I'm going to do it. I'm going to subtract the Y coordinates, X coordinates, and the Z coordinates, square them up, add the value, and then take a square root of them. And this will give me a distance between these two data points. Is it clear, guys? How you can extend this concept for multiple dimensions. I'm just showing it for 2 and 3 dimensions, but you can extend the same concept for multiple dimensions as well. We are going to take a data set and understand how it works. But so far, are we clear how to utilize Euclidean distance to find the distance between two data points? Okay, Sirisha is saying yes. Chandrika, yes. Okay, great. All right, good. So far that you are following how Euclidean distance works, we are going to see that how we can utilize this to find the distance between the data points now. Okay, so let's move ahead. So we looked at, as I said, we can find the distance between two data points A to B, okay, using Euclidean distance, okay. But this is between data point 1 and data point 2. But what if we have a cluster of data points like D1 and D2, okay, and I have a cluster of D3 and D4, okay. So if I want to find the distance between two clusters C1 and C2, okay, the distance between these two clusters is not calculated using Euclidean distance. For that, we have different measures, okay. And what are the different measures? So to find out the distances between the clusters, okay, we are going to work with certain linkage methods, okay, linkage methods. So we have single linkage, okay, which is also called as your nearest neighbor. Now, why is this single linkage method also called as nearest neighbor? Because if you see these data points, okay, so this is data point 1, data point 2, data point 3, data point 4, and data point 5. Okay, now these are all together a part of one single cluster, okay, C1. And similarly, you have these red data points that you can see over here, okay, is a part of another cluster, which is your C2. Okay, now what we are going to do is we are going to find the distance of each data point in cluster 1 and cluster 2 and find out two such data points which have the minimum distance, and that is the reason we call them as the nearest neighbors. And the distance between these two nearest neighbors of different clusters is the distance between these two clusters C1 and C2. Okay, so that is how we define the single linkage method or the nearest neighbors. All right, now going to the complete linkage method. Now what is the complete linkage method? Similar to the single linkage method, we have two clusters C1 and C2, okay, of data points. Now what we're going to do is, in the earlier method of single linkage, we took the closest data points, the distance between the two closest data points, which is the nearest neighbor. But here we are going to take the farthest neighbors, the two maximum distance. So whichever two data points are having the maximum distance between them, okay, that distance we are going to call as the distance between two clusters C1 and C2. So if this is C1, this is C2, this is what I'm going to say. So I'm going to take the farthest distance, and that is the reason this is called as the farthest neighbor distance as well. Okay, so we studied single linkage and complete linkage, which is nothing but nearest neighbor and the farthest neighbor. So far we have seen two. Now we're going to look at the third linkage method, which is nothing but the average. Okay, now how does this average linkage method work? So, am I audible, guys? Can you hear me? Okay, great. So, how does average linkage method work is, we are going to take the distances between data points of, okay, so from one single data point, let me show you. So from one single data point, I'm going to calculate the distance to all the other data points in the other cluster, okay? And similarly, I'm going to calculate the distances from other clusters data point to these remaining data points in the other cluster as well, okay? And take an average of all the distances between the members of both the clusters. And that is how I'm going to calculate the distance between cluster 1 and cluster 2. And this is called as the average linkage method. So far we have seen single linkage, complete linkage, and the average of all distance is nothing but the average linkage. And finally, we are going to look at something called as the centroid linkage. Okay, now what is this centroid linkage? So for that, first we need to understand what is a centroid. Okay, what is a centroid? Now let us say if in a cluster, okay, if in a cluster I have data point 1, okay, I have data point 2, and I have, let us say, data point 3. Data point 1 will have certain x1, y1, okay. Data point 2 will have certain x2, y2, okay. Again, these are on this particular coordinate system. And D3 also has certain x3 and y3 coordinates, okay. Now, how do I find the centroid? Centroid is nothing but the central location of these three data points, okay. So when I say the central location of these three data points, basically, it will be a new point, okay, on this. This is not an actual data point, but this is a representative of these three data points. How? Basically, we are going to find the coordinates of this new centroid, okay. How? So for the centroid, okay, data points, which is xc and yc of centroid, is given by x1 plus x2 plus x3 divided by 3, comma, y1 plus y2 plus y3 divided by 3. So this is how we are going to take all the x coordinates, okay, and take an average of those, and that is what is going to give me the xc. And similarly, I'm going to take the average of all y coordinates of three data points, and that is how I'm going to get the y coordinate of the centroid yc. Clear? Eh? So that is how I figure out the centroid of this particular cluster. So I'm going to find out the centroid of cluster C1, which is this blue data point. It is not a data point, but this is blue cross, okay, which represents the centroid. And for the red cluster, I'm going to find out this particular centroid, which is for the red cluster or C2. So I'm going to find out first the respective centroid locations of both the clusters, and the distance between these two centroids of both cluster is nothing but the distance between cluster C1 and C2, and that is what we call as the centroid linkage method. So far, are we getting this, guys? So we looked at, so let us quickly summarize all the four. Basically, we were looking at the linkage methods. Okay, so first we looked at single linkage. Single linkage is nothing but the nearest neighbor to closest data point of both the clusters. Okay, distance between them is nothing but the distance between these two clusters. Okay, then we saw the complete linkage, which is nothing but the farthest neighbor, the two data points of each of these two clusters which are very far from each other. That distance we are going to consider as distance between the two clusters. Mean link is nothing but the average linkage, which is nothing but the average of all the distances between both the members of both the clusters. Distance between centroid is nothing but we need to first find out the centroids for both the clusters, and the distance between the centroid of both the clusters is the actual distance between the two clusters. Okay, so these are the four different methods when you want to find out the distance between two clusters. When we want to find the distance between clusters, okay, cluster to cluster, and data point to cluster as well. Okay, and data point to cluster as well, we go with all these linkage methods. And when we want to find out between data point to data point, okay, when we want to find the distance between two data points, we use the Euclidean distance. Now, why have been we discussing all these points so far is, okay, when we first find out the distances between each pair of data points in our data set, we use the Euclidean distance. But as we keep on merging two or more data points based on the distance based similarity, okay, we start forming the clusters as well. Then we have to figure out the distance between data point and cluster, and from cluster to cluster, similar to what we saw over here, right? In this particular example here. So first, individually, we have all the data points. Then we find the distances between each of the data points with respect to each other. Then we figure out which two data points are close to each other, and then we merge them together to form a cluster. And then we need to find the distance between a data point to a cluster and from cluster to cluster as well. And when we want to find the distance between data point to cluster and cluster to cluster, that is when we are going to use all these methods, guys. Clear, everyone? Yes, Khushi, it is applicable to more than two clusters. Just for understanding purpose, we have taken two clusters. All right, guys. So let's move on. So let us take a simple example. Okay. So let us say we have 5 observations. Okay. Think of this as your data set. Okay. This as your header. So we have two variables, V1 and V2. Okay. And I'm going to plot these each data point. So this is one data point 1. This entire row is data point 2. This entire row is data point 3. Okay. Likewise, we have 5 data points. All these 5 data points we have plotted on a coordinate system like this. Okay. Now, as you can see over here, okay, we have 5 data points, and we are going to find out the distance from this first data point to second data point, this first to third data point, first to fifth, and first to fourth data point as well. Okay, using something called as Euclidean distance method. So we are going to construct this Euclidean distance matrix. Okay, basically from first data point. Okay, so from the first data point to first data point, the distance from self to self will always be 0, right? So खुद से खुद का distance हमेशा 0 रहेगा. Then we are going to find out the distance between first data point and second data point. This distance we are talking about. Okay, using the Euclidean distance, it comes out to be 1.0. So from first to third is 5.0. From second to third is 4.5. From third to third, again, it will be 0. So that is the reason you can see that on the diagonal, distance from self to self, second to second, third to third will always be 0. So the diagonally all values are 0. Okay. But the remaining distances have been figured out using your Euclidean distance method. Now, coming to the very first step of our hierarchical clustering is to determine which two data points are having minimal distance. Now, tell me, guys, which is the minimal value apart from 0 in this entire matrix? Which is the minimal value? Yes, Suresh Babu, 1, right? 1 is the minimal value. So we can say that data point 1 and 2 are very close to each other, as it is very much evident from this particular graph as well, right? So we are going to merge these two data points into one single cluster. Okay, we are going to merge it into one single cluster and call it as cluster A. Okay, and then we are going to find out distance between cluster A to data point 3, distance between cluster A and data point 5, distance between cluster A and data point 4. So for that, we are going to construct another matrix like this. Correct, Khushi. So first, let us go step by step. So we merged data point 1 and 2 because it was having the minimal distance. So we created a cluster A. So if you see here, there is no 1 and 2 over here. We have no directly cluster A now and the remaining data points. So we are going to use the single linkage method. Now remember, when we want to find out the distance from data point to cluster and cluster to cluster, we need to use the linkage methods. We can't use the Euclidean distance now. Okay. So for that, we are going to use single linkage and we are going to find the distance between cluster A to data point 3, which is 4.5, from A to 4, which is 7.8, from A to 5, which is 6.7, and the remaining data points are already there, right? Now tell me which is the minimal distance between all these distances over here in the matrix. Which is the minimal value in this entire matrix now? Apart from 0, which is the minimal value? 2, exactly. So 2 is the minimal value, which means that the distance between data point 4 and data point 5 is the minimal. And we need to merge this 4 and 5 into one single cluster and call it as cluster B. Okay. So that is what we are going to do next. So we merged data point 1 and 3 to create cluster A. Okay. And here we are going to see that we have 2, which is the minimal distance. Okay. And that we are going to use to merge into something called as cluster B now. So we have cluster A and cluster B now. Okay. And we are going to find out the distance between data point A to 3 and distance between two clusters A and B using the linkage method, single linkage method. Okay. So we found out the distances and we found out these are the distances. Now tell me which is the minimal distance now. Which is the minimal distance? Minimal distance apart from 0 is your 2.2, which is between 3 and B. So we are going to merge data point 3 with cluster B, okay, and then form one single cluster B now. So as you can see at the end of the process, we just have two clusters A and B with 4.5 as the distance between them. Okay. Now this was the entire process of hierarchical clustering. Okay. But what next? How do we conclude this hierarchical clustering process? So for that, we use something called as a dendrogram to summarize the results of our hierarchical clustering. Now, what is this dendrogram all about? The dendrogram is nothing but a representation of, okay, all the observations. Remember, we have 5 observations, okay, all are plotted over here on the x-axis. On the y-axis, okay, we have something called as these representations, okay. What are these representations? These are nothing but this height of this particular dendrogram represents the distance, okay, between these two data points. As you can see, 1 and 2, okay, were having the minimal distance, and that is the reason we clubbed them together to form a cluster A. Then we found out that 4 and 5 are very close to each other, so we merged them together in a cluster B. And later on, we also found out that data point 3 is also closer to 4 and 5, and that is the reason we together created a cluster B as well. Okay, and then finally we merged all of them together to create this hierarchical structure. Okay, that is why we call it as a hierarchical clustering. Okay, now how to make sense of this particular dendrogram? Okay, so these are nothing but the group of similar data points that you have found out based on the distance based metric, which is your Euclidean distance. Okay, so from a business perspective or application of business, I mean, how do we apply this in real world, right? So from an application of this into the businesses, what we do is think of these as your customers. Think of these as your customers. Okay, and we have created groups of customers. So this is, let us say, group 1 of customers, and this is your group 2 of customers. Okay, we have created 2 groups of customers. Okay, and we are going to say that, okay, these are all similar customers. Assign them to the marketing and sales team. Marketing and sales team. Okay, tell them, okay, look at the characteristics of these customers in this group 2. Okay, maybe based on their income group, based on their age, based on their spending patterns. Okay, it can be any criteria. Okay, based on that, design some credit cards so that we can offer those credit cards to these particular group of people. Okay. Again, we are going to assign this group 2 also to another member in the sales team, sales and marketing team. Okay. And we are going to tell them that, okay, this is another group of people, okay, which are similar to each other. You can look at the characteristics of these customers and design a different credit card or design a different promotional offer for these different customers in group 1 as well. So the idea to group customers into different groups, group 1, group 2, maybe there will be a group 3 also getting formed. Okay. The idea to cluster them or create different groups of these customers is to look at the characteristics of those customers which are similar to each other and create certain promotional offers, credit cards, products, anything. You can apply them in any business logic. Okay. So this is entirely how your hierarchical clustering works, guys. So far, are we clear? Any questions, queries, doubts? Is everything clear? Have you understood the concept? Okay. Sankirtana, yes. Kushi, yes. Okay. So guys, once we have understood how hierarchical clustering works, it is very easy to understand how your k-means clustering also works. Okay. So we are going to look at now the other technique, which is your k-means clustering. Okay. So let us go to k-means clustering. Okay, I'm going to show you this dendrogram. Okay, one more slide on dendrogram. So this is how your dendrogram, okay, you need to cut this dendrogram. So for example, over here we have these group of customers into one single cluster, these group of customers into another cluster. Okay, and this is the third group of customers that we have in the third cluster. Okay, so as you go above the dendrogram, right, what is happening? You are creating dissimilar. So basically similarity increases as you go down the dendrogram. Similarity increases as you go down the dendrogram. Means what? As you go towards the lower parts. So if I cut the dendrogram over here, look at this particular thing. If I cut the dendrogram over here and if I pull these strings out, I'm going to get 4 different groups of clusters. So I can call them as group 1, 2, 3, and 4 clusters. So if I have 4 members in my sales team, I'm going to assign all these 4 different groups of customers to each of the sales department people and ask them to create customized offer for these all similar group of customers. Okay, so that we can have increased business with all these customers. All right, so that was how your hierarchical clustering works. Okay, we apply hierarchical clustering to basically small data sets. Okay, because of the computational complexity involved for calculating the distances between each of the data points. Okay, we use Euclidean distance to find distance between each of the data points with respect to the other data points. All right. Okay, now let us talk about k-means clustering briefly. This is again another type of clustering technique. This is very much simple and easy to understand and is widely used. Okay, because it can be applied to larger data sets as well. Okay, whereas the drawback of hierarchical clustering is that since there is a lot of computational complexity involved, we can only apply that technique to smaller data sets. Okay, and the number of clusters getting formed is also subjective, in the sense we have to find out, okay, we need to determine how many groups we want to cut the dendrogram into. So you can cut the dendrogram into 3 groups, 2 groups, 1 group, based on whatever is your capacity of the marketing and sales team. Okay, or basically how many promotional offers you want to create, how many clusters you want. Okay, based on the similarity, you can cut the dendrogram accordingly in that particular fashion. Okay, and that is the drawback of your hierarchical clustering, that you cannot apply this to larger data set. So for larger data sets, we have something called as the k-means clustering. Okay, so I'm going to briefly explain k-means clustering, how it works. Someone on the chat. Yes, agglomerate and hierarchical clustering are one and the same thing, Kushi. That's correct. Okay, now I'm going to briefly explain you how a k-means clustering algorithm works. Okay, so I'm just going to show you. I'm going to just write the steps. Okay, of k-means. So in k-means clustering, okay, the very first steps, okay, is to determine the value of k. Now, what is k over here? Okay, k is nothing but you need to determine upfront how many clusters or how many groups you want to form of the available data set. Okay, so let us say if this circle is representing, okay, your entire data set, and this condition is that k should be greater than or equal to 2. Okay, so minimum partitions that or minimum groups that you should create is minimum 2. Okay, let us say I determine the value of k is equal to 3. I say that the value of k is 3 now. Okay, so what does this k equal to 3 mean? It means that divide the data set into k. K is nothing but 3 non-overlapping random partitions. So when I say non-overlapping random partitions, so basically I'm going to say that divide this into 3 different parts. Okay, so this is your partition 1, this is your partition 2, and this is your partition 3. Okay, I have randomly divided into non-overlapping, okay, non-overlapping partitions. Now, what is the third step? Determine the centroids for all partitions. Okay, so since I have 3 partitions over here, I'm going to have 3 cluster centroids. Okay, so I'm going to have 3 cluster centroids for each of those partitions. Okay, now there would be certain data points in each of the partitions. Okay, so there will be data points all scattered over here. Okay, so let us say these are your data points. Okay, now what is our goal here is fourth step. Okay, find the distance between each data point to all cluster centroids. So when I say all cluster centroids, okay, let us say that I'm going to take one data point over here. Okay, let us say I'm going to take this particular data point. Which one? Let me take this one. Okay, data point. Okay, now I'm going to find out the distance from this particular data point to cluster C1, to cluster C3 centroid, and to cluster C2 ka centroid. So I'm going to find all these distances D1, D2, and D3. Okay, now what do we do next? So find the distance between data point to all the cluster centroids. Okay, fifth step, find which is the minimum distance. So which means that whether D1, D2, or D3, which is the minimum of all of these. Okay, so you have to find out the minimum of all of these 3. Okay, so let us say D2 is minimum. Okay, D2 is minimum distance. Now tell me, if D2 is the minimum distance, which means that this data point is closer to cluster 2 or partition 2 centroid, which is C2. Okay, but is it lying within C2? Is it a part of C2 cluster? No, right? It is currently a part of C1 cluster, right? It is currently in this C1 cluster, but it is actually closer to C2 centroid. All right. So the next step is move the data point to closest cluster centroid. Okay, closest cluster centroid if it is not part of that cluster. So if it is not belonging to the same cluster to which it is closest to, we need to move this data point from cluster 1 to cluster 2. So we need to move the data point from C1 to C2. Okay, now since there is a movement of data point from C1 to cluster C2, the number of data points. So let us say if this number of data points here was 30, here it was 20, and here it was, let us say, 40. Now, since we have moved this data point from cluster C1 to cluster C2, the new values, okay, so basically the number of data points here, instead of 30, this will become 29. And instead of 40, this will become 41. Why? Because we have moved this data point from cluster C1 to cluster C2 now. Why? Because it is closest to centroid C2. Now, because of this movement, what has happened? We need to recompute the centroids because there has been a movement of data points. Recompute the cluster centroids. Okay. And the final step is repeat the steps until no movement is possible. So basically, we need to do the same operation for all the remaining data points such that all the data points, okay. So after applying clustering, right, what would be the to-be structure? Let us look at that. After running the k-means hierarchical clustering, okay, what would be the result, end result? The end result will look something like this, guys. So this is your C1, this is your C2 cluster, and this is your C3, okay. These are the respective centroids, let us say. This is your C1, C2, and C3, okay. And after the entire clustering process is finished, okay, what will happen? The data points will be very much closer to their respective centroids, okay. And since they are all the data points are closest to their respective cluster centroids, no movement possible, okay. I mean, there is no such data point that we can move to the other cluster stating that, okay, it is closer to that particular centroid, and that is the reason we need to move. So we will do all those such movements for all the data points which are closer to the respective centroids, okay. And after doing all that, the algorithm will stop when no further movement is possible. So at the end of the algorithm, what will be the result will be all the data points will be clinged or very close towards their respective cluster centroids. So this is how your k-means clustering works, guys. So Kushi, yes, we can do that. We are going to look at an example and see how this actual movement happens. But is the process clear to everyone, what we have discussed so far? Is the process of k-means clustering clear to everyone how it works? Or do we have questions? So second diagram, explain again. Chandrika, so basically this is at the end of the algorithm, okay? So after applying k-means, so after you run k-means, right? After you run k-means algorithm, what would be the end result look like? All the data points which are earlier scattered, because we randomly partitioned the data set, okay, into 3 different parts. We said that k is equal to 3, right? Which means that we will divide the data set into 3 random partitions, okay? And then we will start clustering, forming the clusters of similar records. Basically what, whichever, based on the distance metric, we are going to move the data point to its closest cluster centroid. So basically, if I take a data point over here, okay, and find out, okay, this is very close to C3, then I need not move this data point. I'll keep it there itself. But if there is certain data point over here, which is more closer to C3 than your C2, then I need to move this data point into this particular cluster, to the cluster, to whose centroid it is closest to. Okay. No, we are not saying clusters which are equidistant to each other. We are saying that the records, the data points will be close to their cluster centroid. These are centroids, cluster centroids. C1, C2, C3 are cluster centroid. Centroid का मतलब क्या है? It is the central location of the entire data point. I mean पूरे जो data points है उस particular cluster में उसका central location है वो. We figured out, right, how to find a centroid. We sum up all the x coordinates divided by the number of data points. We sum up all the y coordinates values and divided by the number of data points. That is how we obtain the cluster ka x and y coordinates. Okay, we are going to talk about within cluster sum of squares, Rohit. But as of now, is this clear how k-means works? Are we clear so far? Do we have any questions with regards to the process? We are going to talk about what should be the best value of k. What if there are still some data points which are still not close to the cluster centroid? So let me give you an example over here. If I give you 3 types of fruits, okay, and I'll give you 2 baskets, okay. If I have 3 types of fruits, okay, I mix them all together and I'll give you 2 baskets and I'll tell you, okay, now based on the color, shape, okay, all the different attributes, try to group all the similar fruits into one single basket. So even if there are 3 types of fruits and I have given you only 2 baskets, there will be still one fruit which will not be, similar to either of the baskets. There will be some data points which are not a part of either of the baskets. Why? So if let us say if I give you 2 baskets, okay, and if you put all the apples in there, okay, all the apples, and if I give you another basket and if I say put all the bananas in over here, okay, but now there is another fruit, that is grapes, I have given to you, but I haven't given you the third basket so that you can segregate them into another basket. So what will happen? You'll have to put the grapes, some into this basket, some into that basket, right? So which means that if there are certain data points, okay, which are not close to the cluster centroid, okay, which are not closer to the cluster centroid, they're still far away, which means that they do not belong to that particular cluster. You should have increased the number of k, which means that you should have a separate cluster. Similarly to for grapes, I need to give you another basket, right? Which means that I need to increase the number of baskets, which is nothing but I should increase the number of k so that you can put the grapes into the third basket, and that is how you can create 3 different clusters for 3 different kinds of fruits. Are we getting this, guys? So in that case, Gangotri, you should keep it in the same cluster to which it is currently in. Okay, to answer your question. Okay, cool. But how to understand nominal value of k at beginning? Yes. So now, as I said, right, if I give you 3 types of fruits and I give you 2 baskets, right? So it is difficult to determine what should be the number of k, right? So to determine the optimal value of k, okay, we have certain methods which we will discuss, okay, based on which you can determine what should be the ideal value of k, using which you should perform your k-means clustering. All right, so that we will discuss tomorrow, since we are short on time. We are already it's 9 p.m. okay, so we'll discuss the final part of what should be the optimal value of k, what is within the cluster sum of squares, right? All that stuff we will discuss tomorrow. But I hope today we have got an idea about what is supervised, what is unsupervised machine learning, what are the difference between those 2 techniques, right? We discussed few correlation related concepts, right? And then we also discussed about 2 techniques from the unsupervised family of techniques, which is nothing but your k-means clustering, and we discussed about hierarchical clustering. We will conclude the remaining part of k-means clustering in tomorrow's session. Okay. So, but so far, was the session good? Are you guys enjoying? Is machine learning interesting? Okay, cool. Is hierarchical supervised? No, Khushi. Hierarchical clustering is unsupervised. Today, whatever we learned is regarding all unsupervised machine learning. Okay. We would be learning about supervised machine learning. Probably it's on the agenda for tomorrow, or I don't know if it is day after tomorrow. But yes, we are going to cover supervised machine learning as well. Don't worry about it. All right, guys, then that's all for today from my side. Over to you, Amar. We'll continue tomorrow as well, guys.
Yeah, sure. Thank you so much. So guys, if you have any query or question for me, please drop in the chat box. And one more thing, I already shared the attendance link. So please mark your attendance. Yes, Rohit, we'll upload that material in the LMS. You're welcome. So there is one question regarding the certificate. So guys, we share the certificate after the completion of the program, but 60% attendance is mandatory. Gangotri is saying if we accidentally fill the attendance link twice, okay, no problem, but try to fill it once only. If possible, send day one attendance link. Sorry to say, but attendance link is open between 8:30 to 9:30 in specified time. No, that's why we're not able to share the yesterday's attendance link. Okay, today's attendance link I'm sharing with you guys. Please mark your attendance. So yesterday I did not attend the class. Today is my first day. Can you provide the certificate? Yes, Shweta. Anyway, 60% attendance is mandatory. So for first day, you can go through recordings. So Rohit, you can follow us on LinkedIn and Instagram. So we are sharing all the details over our social media platforms for regarding to the upcoming programs. Kushi's question is there. So yesterday I have logged into the ExcelR website and I'm able to access video. Is that only the LMS? Yes, Kushi. Rohit, you can search with the ExcelR solutions. Guys, anything else? Sakshi sir, I can't give yesterday attendance. Okay, Sakshi. But there is no any another option for me. No one. Okay, I think there is no more questions. So guys, thank you so much for joining the session. We'll meet you on tomorrow at same time.